And like I said, I go into this a little bit in the presentation. I bought this 4 years ago. So I've got an older camera, older Pi, and like I said, it's got no problem. So it's not like we have to have the latest and greatest for this stuff. I will, like I said, the talk's not too long. So at the very end, I will go into the Raspberry Pi and fire everything up. There is an issue with printing what the camera shows, but we can work around that. So none of the Raspberry Pis have the GPU on them. You'd have to buy a separate card for that. And there's tons of options out there. Like I said, I haven't dug in too much into that, so I would just be speculating as to what's the best. And I do have all this code in on my GitHub. And I believe the link for all of that is on my speaker profile. And I also uploaded this presentation to the Dropbox. So you'll be able to see it afterwards if you don't catch a screenshot of it. And it obviously would be ideal if we were in person so you could play the Raspberry Pi, but we'll have to make do. And I have, like I said, I've done this twice remotely. It's not too bad. And I did post this morning. You can click ahead if you hate the sound of my voice. I've got the presentation up on my website that links to my GitHub profile. Wait another couple minutes here, so don't leave anybody out. Emily, are we doing, is there going to be an introduction for me, or am I just going to start at 10? I can't remember what was said in all the emails.
Hi, sorry. I meant to get on and share my video with you earlier. I had to re-log out. All of my stuff was freezing. Yeah, I'll just introduce you really quick, just basic.
Okay.
Hello, welcome to the breakout. I meant to get on. I just got back in. Sorry about that. We'll just give everyone a couple more minutes. I know, navigating around sometimes. All right. Hi, everyone. I'm just here as your AIM moderator. If you guys have questions throughout this session, I'll be monitoring the chat. I'm not super sure if we'll have a ton of time at the end for questions, but the nice thing about these breakout sessions is you guys can kind of stay on as long as you need to after the session is done to ask those questions. Here with us is Evan Hennis. He's going to be presenting to you today, and I'm going to leave it to him now.
All right, let's go back to my introduction here. Thanks for the introduction. I should be able to see comments. If you guys type something up, I can answer them for you. So my talk is computer vision of the Raspberry Pi, and it's just setting up a Raspberry Pi for image processing. The point of the presentation is just to show how easy it is to get going, because I've noticed that with me personally, that first step's always the hardest, especially when it comes to hardware, because I'm not truly a hardware person. Always on the software side, but I have been fascinated by the Raspberry Pi. So anytime I get a project to work on that, I like to take advantage of it. I am a Google developer expert in machine learning. I've had that for 2 years, I believe. And there's my Twitter handle, my blog, and my GitHub. And then I do have a YouTube channel. I think I made 2 videos. I don't use it too much. I did stream some stuff once upon a time, but not a whole lot there. Here's all of our presenters. I had that up when we were waiting. Check all them out so they keep coming back. My bio, I got my undergraduate from Iowa State in 2004. I then got a master's from Georgia Tech, completed that in 2018. I did go through their online master's program, which is awesome, and I recommend it to anyone that's even thinking about going back to school. It's well under the limit that most companies will pay for. I think I got through with it just under $8,000 over 3 years. I did 9 straight semesters. My day job is a .NET developer. I've been doing that since 2004. I got my GE in 2019. I have switched over a little bit in the machine learning world, mostly personal projects and things like that. So here's my family. This is 4 years old. The blonde girl is at home. Her middle school teachers are all quarantined, so hopefully she's busy for the next 45 minutes and she doesn't barge in. But if you do, that's going to be her. This is an Android app I wrote with my daughter and my nephew. So if you're into Android and fishing, it's kind of a neat app. I do have a deep learning project for Manning Publishing. It's getting ready to be fully released here pretty soon. But right now it is the early access group, and you get it for cheaper. And it's really just a project I did after I got out of grad school, grabbed a bunch of data from college basketball, did a deep learning model on it and tried to predict it. So if you want, you can check that out. Now, for this presentation, I'm going to start with an introduction, and then I'll show you the hardware that I used. Then I'll talk about the camera and the API that Raspberry Pi put out that makes it super easy. I'll talk a little bit about putting TensorFlow version 2 on an ARM processor. It's not supported fully, but there are ways around it. I am using MobileNet v2, which is part of the TensorFlow library. It's a pre-trained. I don't have to go through all the training. I will then walk through my code and deployment and do a short demo. I will then do a TensorFlow Lite update. And relating back to the TensorFlow version 2, the stance from Google going forward is TensorFlow Lite instead of using TensorFlow mobile or any of the other versions they had or variations. It's a super easy process. I've done it for this project. And then going back to that Manning project, I've extended that, and I have that on the Android application using TensorFlow Lite as well. Then I talk about future projects, and then I do a conclusion. So here's my project. Here's my hardware. Like I said, I have Raspberry Pi 3. I originally installed Raspbian. They have since rebranded that as Raspberry Pi OS. They had some confusion. They said they had confusion on people connecting Raspbian to Raspberry Pi, so it's been renamed. I do have that updated on mine. It's exactly the same. They really just changed some labels. The camera I'm using is the V2 8 megapixel. It is probably 4 or 5 years old, and they've had some massive upgrades to their cameras. So you can get a lot clearer pictures and a lot better pictures, but for my project, it doesn't matter. Leigh Johnson, who is a fellow GDE, she gave me the idea for this project. And if you're here earlier, I was talking about her. She's taken it way further than I ever have. So if you want to get into more nuts and bolts, go to her Twitter and her GitHub. She's got a fully deployable Raspberry Pi setup. So it's pretty cool. So for the Raspberry Pi setup, you do need an SD card. It has to be at least 8 gigs. That'll get you the full version of Raspberry Pi OS. I don't have anything special on my card, so I could have gotten away with an 8 gig. If I was going to have a bunch of training stuff, a bunch of versions, a bunch of models, I would need to upgrade that a little bit, but for me, 8 would have been fine. Having said that, I had some problems with the SD cards I currently had. Mostly it's a user error. There is a button on the card that made it read-only, and I wasn't smart enough to figure that out. So I ended up buying a new card, and why get a small card when you get a huge card? So I bought a 128 gig. The problem with that, it only recognizes 32 gig at a time. So it was a complete waste of doing it bigger than 32 because you basically have 2 partitions, and for what I don't need 2 partitions. So that was dumb, but whatever, live and learn. And then, like I said, I put the Raspberry Pi OS. You can use Noobs. They have a lot of the similar stuff. I do like the Raspberry Pi OS because it comes with everything you need. As I'll show in a second, the IDE comes built in. It just works out of the box, so that's really nice. So my camera is a simple 2 megapixel camera. And I am using the Pi Camera API, which is installable using that sudo command. It's a fantastic API. It's everything you need, easy to code again. So there's very little friction to getting the camera actually up and working. I originally built this. I was going to make a camera when my daughter was born, and I was going to just drop files to the network. Well, it turns out that she started sleeping through the night, and it wasn't worth my time anymore. So I kind of put it on pause until I built this project. So TensorFlow version 2, which came out 2 years ago, doesn't support the ARM processor. There is a wheel file, which I show a link at the bottom, which does work. They are pushing for TensorFlow Lite, so I don't see them changing or compiling against an ARM processor. Microsoft does have an add-on, and I can't think of the name, that lets you run full-fledged TensorFlow on the board. I should have grabbed a link for it, but I didn't. But if you're into that, you can check it out. It's just something they plug in on top of the Raspberry Pi, and it's designed for machine learning. So I mentioned earlier, MobileNet V2 is a pre-trained image recognition model. I'm only using V2. V3 is out, but I didn't need it, and 2 was the good one when I was out. As I mentioned, it is pre-trained. It is part of the TensorFlow distribution, so I can just use it, TensorFlow Keras application.mobilenet, and I have everything I need. So that was an easy way for me to just get up and running and not have to worry about training my own model. So the camera code is really super simple. I like to make a lot of classes in my Python code. So I just made a wrapper basically. So the Pi camera that is right here, that's the API. You really create the camera, you set your resolution, your frame rate. 24 is mine. If you have a GPU, you can obviously speed that up. I do have to flip, so the picture matches what is trained in the model and how I mount my camera. if I would mount my camera sideways, obviously I have to flip accordingly. And you see I do rotate because of how I have my camera. And then I just start streaming. I just capture continuous. I drop it in the data container, which is an array here, and just run it, and it runs. So when this fires up, my camera is constantly taking pictures, constantly filming, constantly going, and then I feed it into my model. So my streaming is as simple as getting the stream from the continuous that I showed earlier, create the array, and then I always save it in the self.frame. And then I have code here if I want to stop it to quit, but I don't need it for mine because I just stop it every time. I just turn it off. And then the camera code, I really just return self.frame, and then I slice it up the picture that I need. So that's how I take the live picture and put it onto my model. If you would have an existing image or whatever you want to train on, maybe you have a static set of pictures you want to look at. In the case of my Android app that I showed, I'm going to put some machine learning. So after you take a picture, it's going to determine the fish for you. I don't need a stream doing that. This is just for live. This is the actual extra code you need to have a streaming app versus the hard-coded images. So MobileNet, like I said, just do some imports. You grab the model, you grab pre-processing and decode prediction. These are built into the library. They just handle all the dirty work of getting your image put in and then decoding the predictions coming out. You don't need these, but if you have them, you might as well use them. So initialize the MobileNet. I just use the Keras application MobileNet and I initialize it. Alpha I did of 1. This is pretty default. I'm not training anything, so these don't necessarily matter. Well, they don't matter. So a lot of it's just default settings. The one thing you do have to have is when you set the weights. Now, I'm not sure if you know much about deep learning. Weights are the values inside the neural network that helps the prediction. This, using ImageNet, basically says, I want the weights that are the final version of ImageNet. So this keeps me from having to retrain. So say, give me my weights, I'm done. So the predict, which is what you're trying to do. This prediction is when, okay, I've got the picture, tell me what it is. And it's as simple as creating the sample, using the built-in pre-processing input to get the sample, then predict on that sample, you get your features back out, and then decode predictions, then makes it into a nice little array. If I was doing more with this, I would take this decode features and then try and manipulate it a little bit. It really is just an array with a percentage of confidence and the percentage of confidence, what it is, and I can't remember what the third column is. But if I was to do something better and just spit it out to the console, I would decode these. Okay, my first one is this, my second one's this, or maybe set a threshold. If it's over 70% confidence, I'm going to tell you what it is, things like that. And this is all manipulation you do on that array. But again, I don't. I just spit it out to the console window. So here's the main code. I'm really just looping. If the camera's not stopped, keep running. And then I do the simple read method, which I showed earlier, pass that frame into the model and predict it. So pretty simple. Now, this is a video, but it doesn't work. So I got to bring up my actual movie. Just close it. So I'll show this for real at the end. The issue I run into is right here to the left is the output from the camera. The Pi camera just spits out to it just spits out to the output, the I/O. Well, when you RDP into the into it, that's not the I/O. That's routed. So if I would physically plug my monitor into my Raspberry Pi, I do get an output of what's being shown to help you kind of gauge if it's a good prediction or not. And this is trimmed down quite a bit. I'm running the code on the right. I cut out about 30 seconds of it loading up. So in it runs, you'll start to see the array get spit out. And a leopard's one of the pre-trained images, and it's pretty distinct. I have a goldfish, but it kind of freaks out a little bit on what type of fish it is. And then there you see the array at the bottom. And if I can point out, you've got, let me just catch up a second. Just doing punching bag. You'll eventually get to, I get focused on the leopard. So you see here, you've got the ID of the class, you've got the leopard, and then you got the percentage. So 86% says this is a leopard. And that's really the entire project. It's that easy. And then, like I said earlier, you can figure out if you want to do something more with it. If you want to do a fancy user interface or anything like that, you'd then build on from that. So that's the first iteration. That's the 6-month-old, didn't have TensorFlow Lite yet. So now I'm going to show you my conversion to TensorFlow Lite. It's super simple. Again, TensorFlow has a conversion library. So you just say convert. And I have a link to a Jupyter model or Jupyter class. My goodness. Jupyter notebook that shows how to do it. It's a couple lines of code, not a huge deal. And I should have opened this up before I started. If you didn't know, in GitHub, if you change this, I think it's GitHub collaboration, it'll open in actual Google Colab. But for now, I'm just going to show you in GitHub. And it's as simple as grabbing the base TensorFlow library, loading the models up here, and you create the model, which I just did in the code earlier, and then you call the convert. TF Lite converter from Keras, boom, there's your model or your class. Call convert. This is now your TF Lite model, and then I save it. So it's as simple as that. It's super simple to do any sort of conversion. I'm biased. TensorFlow and Google do a fantastic job of being able to convert full-fledged TensorFlow models to other types. So if you're doing a website, Tensorflow Js, super easy conversion. It makes it really easy to train on some heavy hardware and then deploy it to multiple locations without a whole lot of work. Okay, so with that said, so we got TensorFlow Lite. So I've converted the model. You then install TensorFlow Lite. For what I did, I'm only using the prediction section of TensorFlow Lite, so I can just use the interpreter. It's a super easy thing to do, and the install is really small. I don't know the exact size right now, but all you're doing is, oh, I know the weights. I know what I'm coming in. Here, I'm going to tell you what it is. So I just need the interpreter, don't need everything else. And then you'll create the interpreter, and then you go from there. So back to this. Okay, so I just showed the model conversion. I guess I did a screenshot of that. I forgot that. The TensorFlow install, there's a really good guide on tensorflow.org. They're doing a really good job with all the documentation. And it's part of the reason I got into the GD program was I was helping with documentations, examples. So if you go to the actual install guide for Python, it shows you how to do it. And then here's the actual command. You just do a pip install of their wheel. So here's a TensorFlow Lite interpreter. As I told you, we only need a subset. For the sake of this presentation, ignore this line here. I am still referencing the full-fledged TensorFlow. If I truly wanted this to be just Lite, I wouldn't have this line of code there, and I wouldn't use those processing. I'd use a Lite version of it, but I didn't. It's just something I left in there. So for the initialization, you show the location of your model, and then you create an interpreter with that path, allocate the tensors, and then you get input and output details. So this tells the interpreter everything it needs to know. If you come down here to the predict, it's very similar. You're still doing the sample the same way. You're doing the pre-processing. And then the difference is the interpreter you call set tensor. So you put your input details, which you created up here, and then the process sample, and then call invoke. That evoke says, okay, run the model, predict what's going on. And then you get the tensors out. And that tells you, using the output details from up here, it tells you what it is. And that gets your features. So your only difference in code between Lite and the full-fledged TensorFlow is these 4 or 5 lines right here. Everything else is the same. The main, again, since I use classes, I changed the class, and then I use that to predict. 2 lines of code, I went from full-fledged TensorFlow to TF Lite. So future projects, you can use what they call transfer learning, which basically says, I'm going to take your model, but I'm going to customize it for myself. So I'll take your model, I'll lock the weights on the first couple layers, and then I'll post in my stuff. So an example is if I wanted to do maybe my pets, I keep the existing model, but then I train on a bunch of pictures of my dog, fish, turtle, whatever pets you have, and it kind of customizes to your stuff. So you can use transfer learning for that. You can also do it with people in your family. So if I wanted to have my Raspberry Pi set to turn lights on, so if I walk in the room, the light comes on. That'd be a way to do transfer learning without having to do all of the training. You can implement object tracking, which what Leigh did in that presentation or in her project I based this off of. You can do home automation, turning lights on and off. Maybe my daughter never turns her lights off, so if I see a picture of her walking out, I turn her lights off for her. There are some really dumb projects of people. One kid had a servo that just kicked a clock off the wall if you walked up to it, so you couldn't tell what time it is. Just stuff like that. And it really, the sky's the limit. It's whatever you can think of, you can do. So yeah, it's, I don't know, like I said, it's almost infinite what you want to do, what you can do. So to wrap this all up, it's simple. Like I said, I walked through in 20 minutes, and it probably takes you an hour to do. Use a pre-trained model. You don't have to have any of the processing power, any of the processing costs, easy installs, and then you get results right away. It's cheap. Like I said, I think the Pi is still $35, camera's $30, and then an SD card. I'm not sure about the Mini, if that works or not. I haven't tried it. And then it's super easy. Like there's nothing in here that, you know, I couldn't train my 12-year-old to do. So it's easy. So here's some links. Leigh Johnson's project, she's built on that quite a bit. The camera API. If you want to stay with TensorFlow 2, here's the wheel. Here's the actual technical paper on MobileNet, how they did it. MobileNet does have set classes. So if you go to this link, it tells you what can actually detect. So if I put up something random, it wouldn't know it because it was never trained on that. You need to make sure it's one of these classes. And then here's my, my GitHub repository. And then here's my information. So the question in the chat, is there any limitation on computational capacity on the Pi? So all of mine is on the onboard processor. And that was enough for my 24 frames per second. And I don't know the limitations on it. I'm sure it's out there. If you can, I'm sure it's easily Googleable. If you want to do more processing on it, maybe detect quicker, it is recommended you do a GPU. And I'm not doing any overclocking on my CPU, and it works fine. Like this implementation has no issue. It doesn't get hot. It can run for quite a while before I even need to worry about it getting hot. But yeah, it all depends on what you want to do. If it's something simple, you don't need the GPU. But if you're going to all of a sudden have bigger pictures, if you're going to do a lot more stuff with it, if you're going to have any other heavy computation, GPUs are recommended. So motion analysis, that would be one of those that you would probably want to start looking at GPU if you will do anything real time. Like if you want to see a person come in, you square them up, detect them, and keep the borders and do any sort of manipulation on that, your GPU or your CPU is going to get a little strained on that. But I don't know the limitation. Like I don't know the line of, okay, this is too much. You should probably offload that to a GPU. I don't do any filtering. I just bring the filter in, or I bring the image in and then process it. I'm trying to think. So in my situation, I didn't need to do anything. I'm trying to think if I would in any of the projects I thought of. But no, I don't do any filtering. or any sort of optimization pre-processing. Is there any other questions? We've got time. You guys can leave if you want. Here, I'll get back to the pie here. So let me stop presentation. So this I am RDP'd into my Raspberry Pi. And here's my setup. So I've got my case, and then I've got my camera that sits like so. And I've got a leopard here, and I'm going to have a goldfish. So I chose the leopard because it's very obvious what it is. Not many animals have those, one, the cat shape, or the, no, come on, or the color scheme. Okay, so fire this up. Like I said, it does take a while to get loaded. It's loading the TensorFlow library, which isn't small. So I just have to wait for it to start spitting stuff out. And like I said, if I would plug a monitor directly into the HDMI out on this, you would see the actual screen I'm showing. So like right now, it's just showing my laptop. So that's why it's predicting a monitor, notebook, things like that. So if I start going into the fish, uh-oh, didn't like it. I gotta make sure my camera's tilted right. And see, it's still showing the screen. And there gets a tennis ball because of the yellow. And see, there it got a goldfish finally. So here's your issues with fish. A lot of fish are trained on this, and you can't determine it that well. And without my guide showing me what I'm looking at, I can't see if I'm off center or not. So then I raise the camera and point it at the leopard. You start seeing it knows where leopard is. You're hitting 90s, gets as low as 60s, but you're in 80, 75 percentile, stuff like that. So like that's as simple as it is. And like I said, I tried other things. So if I showed on my mouse, it thinks it's a catch machine. There's things like that. So it's obviously not perfect. The strength of your model is obviously very important for real projects. Like you're not just going to off the shelf grab MobileNet if you're going to try and figure out what bird is at your bird feeder. You're going to find either a pre-trained model of people that do bird watching, or you're going to train your own by downloading a bunch of images from Google. So kind of how specific you want to get with your project determines what kind of model you use. There is, with any project, there is biases, right? So if you give a bunch of pictures, that's what's going to train on. An example I use, I have a trained model for detecting fish. I kept getting the wrong detection. And what I did was every fish picture that I had of a muskie, which is a trophy fish, has someone holding it. Well, the model started keying off of humans. So it saw a human, it thought it was a muskie. It wasn't actually trained on the fish. So there's a lot of that stuff that you're going to learn when you're doing your testing. Are you really trained? Is your model really generalized to all images, or is it overfit to the images you've shown? There's a lot of that to look out for, just to make sure good data in, you get good data out, I guess. Do you have any other questions, or I guess I've got 10 minutes. I can show you the Android interpretation, just to show you a little different version. What does the process of actually pulling trained models from, you said, Google Images? So the one I trained myself, I just did a Google, and there are tools out there that'll download a bunch of images for you, and then you just feed it in. You do your whole training, testing, validation phase. So for me, I mean, again, I don't know the level of people's machine learning here. You basically say you get 1,000 images of your dog or your type of dog, and then you send it to your model. You try and fit to the model, And then you say, okay, what do you think this is? And then you compare it to what it actually is. You say, okay, well, it really is this. Then it uses the error to figure out, okay, what do I need to change within the neural network to actually detect this image correctly? And then through a bunch of training, they'll eventually figure out how to do it. Like I said, there are tools, I think there's add-ins to Chrome that download everything you see. So that's a big brute force way of doing it. Again, you gotta be careful because I think every Google image has a dirty picture in it at some point. So you gotta make sure you're not training on something bad or something that's not the image you want. So Android Studio is loading up here. I gotta switch projects. It'll be just a second. So that answer your question, or did you have something else? Okay, so in the situation where it's IDing humans, what did you have to do to forget that training and to affect the training it had for other fish? So I really just started the training over. I reset the neural network and said, I'm going to redo all these pictures. So yeah, I basically had to trash what I had. I guess that's, yeah, not ideal, but it's really not that hard. There's some computing time obviously involved for training, but just resetting and starting over, you basically hit stop and hit play again. So it's not like I had to undo what I did. I just had to start over. All right, hold on. I'm doing some Android development of a suite of products. So I go find my existing one. Okay, so here is Android Studio. Now this is the Android app I made for that Manning project as an extension of it. So it has to do with gambling, so it has nothing to do with images, but it's the same general idea. The difference with images, you'll have to do some of the pre-processing stuff on the image, where for me, I just needed numbers. So on Android, one thing you have to add is this options to do not compress the TF Lite model, because it will try and compress it, and it basically zips the ones and the zeros and it screws off the weight, so it doesn't work. So you have to make sure you do that. So the actual code is, so I have just a manager class for my Android. Where's my asset? So here is my model, right? So I load up the model, I pass in the location of it, and then again, just like in the Raspberry Pi, I create the interpreter class. And because I'm passing in an array of numbers, I just build an array. My mouse going all over the place. I build an input array, create a float, and then I do a run. I pass in my inputs, I pass in my float array as an output, close the interpreter, and then release the result. So it's really that easy. Once you converted, that's how you run your model on Android. So it's one of those things where if you had a machine learning model and you want to put it on the web, Tensorflow Js, very similar. Convert the model to Tensorflow Js, use your JavaScript to interact with the tensors, and you're done. You want to put it on a website, you just drop it like that, full-fledged Keras model, then you interact with that. You can put it into the Google Cloud. If you want to do Android, you drop it here. So your same model, your same intelligence is deployed everywhere with just conversions and a code change. So it's really easy. And Google has a ton of products that help you with this. I am not nearly big enough to use it, but if you are an enterprise and you're doing this stuff, it is something to look at. I'm sure everybody does. I just say Google because that's what I'm most used to. Yeah, so Jeremy mentioned someone did set up a Raspberry Pi to detect if their cat had something in its mouth. So the cat came up with a dead bird, they would lock the pet door. And that was it's a pretty creative way to do it. It's the same thing. You see your dog come up, boom, you unlock the door. You see someone else's dog, you keep it locked. There's a lot of stuff like that. It's fun to tinker with. You can get really enterprisey and do a bunch of stuff with it. But again, it's not hard to get there. And it's kind of a fun process, at least I think so. We'll close this. And then just for giggles, here's the, since we have 10 minutes, where let me show, break out my Visual Studio Code, and I'll show you the Tensorflow Js, since I've mentioned it, and there's no more questions. So here's the website I built for that same project. It's a little different code to convert it to the JS extension, so Tensorflow JS can handle it. But again, it's the same. It's essentially the same thing. You put 5 or 6 lines of code in, you do the conversion. So with Tensorflow JS, you create this this model JS, which is basically the weights of my model, right? You come in and you do a simple, you call load. Let me see if I can find the code that actually does it. There's code that just loads the model. Where did I put this? Must be the top. Okay, so I just call this. So this is a JS script, so it's going to run line by line. Use TensorFlow, load layers, and that's a path to my JSON model. I've got my model, and then I've got code that when it's loaded, I just tell the user it's loaded. I do some normalization, which is something you need to worry about with number. I'm not going to get into it here. But it's as simple as you call your TensorFlow tensor.2d, you pass in your array, and you get your input values. You then take your model, which you loaded, call predict on your input values, sync the data, convert to a number, and you've got your prediction. So it's really that easy. All you have to do is these couple lines of code, and you've now got your model hosted in a website for anybody to use. So that's kind of one of the neat things. And I'm sure PyTorch is Facebook's version of TensorFlow. I'm sure they have all this other stuff. I'm not going to tell you that TensorFlow is the only thing to use. It's just what I use. There's no reason to get into a war over frameworks. They're essentially the same thing. You can get the same way, same endpoint eventually. So just because I say TensorFlow, there's other frameworks you can use if that's your deal. I mean, that's really it. That's all I have. If you have any more questions, let me know. There's a way to like IM me in this tool somehow. I think you can look me up and start a chat. Like I said, I'll be around till 11 my time, which is, I'm in Iowa, so Central Time. If there's any questions or any other issues, you can follow me. Like I said, hit me up on Twitter. I'm on LinkedIn somewhat. If there's any other questions. Or you have easy machine learning questions, you can ask me. So Keras is rolled into TensorFlow. Although I use TensorFlow, I don't fully use it. So a lot of times I'm using TensorFlow to get to Keras for my deep learning. I have done some stuff with TensorFlow as far as like setting up a Monte Carlo simulation, where I'm actually using TensorFlow in the actual tensors and doing some research stuff like that. But Keras is crazy easy. It's really creating a class. I want a network. I want these layers. I want these neurons on the layers, and you go from there. It's super easy. For training, a lot of people are going to Google Colab and letting Google handle the hardware stuff. Anything you see that makes the news is probably more expensive than what you're going to be able to afford. I'm trying to think what the new one was that just came out. There was a reinforcement learning library that came out that was something like 1 million days of training, like essentially 1 million days of training. They have 1,000 computers at once and spinning it up. So for my basketball example, it took maybe 10 minutes, 20 minutes to train, but I'm using numbers, and I had 10 seasons of data. So I had like 60,000 games. It didn't take that long to train. I did it all on Google Colab. If I was doing it on my really slow computer, it would take a lot longer. But everything I've seen is people just drop in Colab. And I don't know if Colab has GPU support right now or if it's pre-release, but you can then get into that and it's crazy fast. I had to train so I had a Sudoku app that I wanted to train, and I actually used Azure because I had free at the time. I had one of their fancy servers. I spun up a fancy server with a ton of hardware and let them run it. So it'd be so much faster because it was going to take me days on my local computer. Or if you get a big rig, it takes minutes to hours. So it can be intensive. So if you've got just a regular computer, it's going to be a pain. It's going to drive you nuts because all machine learning is very iterative. So you do something simple, test it, change it, test it, change it, test it. So I'd not recommend doing it on your own computer unless you have a lot of free time. So I guess that's a really wordy way of how to train. Like I said, a lot of people use the cloud. You can, so Tensorflow.js and Tensorflow Lite both allow you to train within their framework. So you can have a website that does the training for you. So if someone goes to it, they can run training in the JavaScript. A fellow GDE did a tic-tac-toe, where you play a bunch of games tic-tac-toe, and then you tell it to train. That takes minutes because it's slow. TensorFlow Lite's the same way in the Pi. You can do it. Personally, I'd be nervous that I'd kind of start to mess up the board if I'm doing heavy training on a Raspberry Pi. And as I showed, transitioning from Keras to one of their models is so simple, there's no reason to force it on there. If you were forced, like let's say you're doing the bird watching app, and if you don't recognize the bird, maybe you save that image off and then you train on it later. That's something you can look into for training. But other than that, anything I've done personally, I've never needed to train on the actual device. I've always used, like I said, collab. And I haven't done too much. So at the point, so 2 years ago when I started in TensorFlow version 2, which is just TensorFlow now, Google Cloud didn't support it. So all the stuff I was doing for the demos, tutorials, I had to do locally or on Collab. I couldn't do in the cloud. They've since fixed that. So you could always put your training into Google Cloud and let them do all the work for you. It's to the point where I don't have issues with overtraining. The question is how often you have issues with overtraining. I don't. There's a ton of safeguards you can put into place. And with something as simple as basketball, I know right away if I'm overtraining because I've got the validation set. Keras also allows you to pass in the validation set, and you can set parameters so it stops training when you overtrain. So I don't have an issue with that. With images, it's a lot harder. Just getting all the images is a pain. I mean, using image, and that's one of the reasons I didn't try and train my own model, is it's just so much more work to collect the images and then label them. So that's why I went pre-trained. It is something, so a neural network will 100% fit your training data if you let it. So it is something you have to be aware of, but as long as you're doing an iterative training process and spitting out the data, you can see, okay, at training epoch 500, I start seeing overfitting. I'm not going to go that far. So yeah, I really don't have too much. I look for it, but very rarely do I like, oh shoot, I overfit. I gotta run that back a little bit. I guess we got 2 minutes left. Are there any other questions? Like I said, I'm on social media, so you can hit me up on that. And I think all my information is saved on this. So thanks for watching and thanks for the questions. I guess that's it. Unless Emily has something else she wants to wrap up with.
Hey, Evan. Yeah, no, that was great. And if people have questions, you can directly message Evan via looking him up in the people tab, and then just send him questions there. All of his information is also there. Also, I just wanted to remind everyone that all of the sessions are recorded, and they will be on the AIM Institute YouTube channel. We will also be sending out an email to all of our attendees with that information on Monday as well, so you can access all of this information again if you need to. So. Really great job, Evan. Thank you.
Thanks. I'm going to
yeah.
I'm gonna drop off. Like I'll be on for a while. People hit me up.
Sounds good. I'm also gonna jump off. So thanks everyone.